Hello and welcome back. We are continuing our lecture. This is second part of 10th lecture. Last time we have done some introduction regarding COAP. So there are some useful terms. Endpoint. So endpoint is a host actually, entity that participates in the COAP protocol, and endpoint is identified as a host. Sender, the entity that sends a message, and recipient, the one that is the destination for the response. Client, the entity that sends the request, and client is the destination of the response. Server, the entity that receives the request from the client and sends back a response to the client. So these are some useful terms in COAP context. COAP message model. So this layer deals with the UDP exchanging messages between endpoint. Each COAP message has a unique ID. So every message has a unique ID. A COAP message is built by these three parts: a binary header, compact options, and payload. The COAP protocol uses two kinds of messages: confirmable messages and non-confirmable messages. So the message that has type of confirmable message. So this means that message must be acknowledged. So when sender sends that message, the receiver is bound to acknowledge that the message has been received. If for a certain period of time the acknowledgement isn't received, then the sender will send another copy of the message. Non-confirmable message. This is a message type where acknowledgement doesn't required. Okay, so this is a sequence diagram of what message exchange process. So we can see there is a client and a server. The client send a message, and the message you can see there is a header CON. Con means confirmable message. This message must be acknowledged by the server. So at the moment, client is sender and the server is the recipient. So the message ID is, you can see it is in hexadecimal format, 8851, and after receiving that message the server responds with the same message ID, and the label of this message ACK means acknowledgement. So sometimes the server is not available to acknowledge something. So at that time it will send a REST message, and it keeps the client to stop sending further messages until the previous message is acknowledged. So you can see the client send a message with a message ID and with a similar format 8851, and the server is not ready uh, to acknowledge that, so server sends RST. So this might be a scenario where client asks server for a certain type of value. For example, the client want to send a message and want to see the temperature, but the server doesn't have a temperature value, uh, doesn't receive any temperature value from the sensor. So the server has to wait for that for until it receives the temperature message. So it send a message RSC to client to that says that hold on for some time, for some seconds or minutes. The other message category is the non-confirmable message. As I told you, now these messages doesn't need acknowledgement, so client send a message. Message ID is 8851 in hexadecimal format, and the non means non it is non-conformable. So server doesn't need to acknowledge that message. COAP request response model. So here you can see there's a sequence diagram, and at one side there is client and the other side is server. So the client request send a message request. Uh, the request is about pressure. So the client needs a pressure value, and the client send a message. The message ID is A8851, and the message type shows that this message must be acknowledged. So there you can see a keyword con. And there's another entity that is token. Token number is hexadecimal 14. And now server acknowledged that your request has been received. So the acknowledge ID is same as the message ID, the request ID, the request message ID. So you can see the server acknowledged the value, acknowledge ID. Let me grab. Uh, so the server message ID is same as this message ID. So this shows that it is an acknowledgement of this message, though it server didn't answer to the request about regarding pressure. So the next, when the server gets the pressure value, it sends the pressure value with the different message ID, and the type is confirmable, means when client receives that message, the client should acknowledge that this message has been received. And the message ID is different. So this message ID is not equal to this. So this message ID is not uh, the same ID that previously we have seen that in the range. And it sends hectopascal value, 1000 hectopascal value. This is the response to this message because the client was interested in pressure. And you can see the server is sending a token ID. The token ID has the same value as the token ID which was in previous request. So this means this is a new message. So the token ID means this is a reply to that specific query on get pressure. And upon receiving this, the client is bound to acknowledge the message. So this time you can see the you can see the message ID is same as this one because this is the response, this is acknowledgement of AA52 message. Alright, so let's move on next slide. Okay guys, this is the COAP message format. We have some binary part and options part and then payload. So the first one is the version. It is a 2-byte unsigned integer indicating the version or the message format. And T is a 2-bit unsigned integer indicating whether this message is a confirmable message or non-confirmable message. And TKL length is a token length, is the token for 4-bit length. So there will be we store token length. And the code, it is the code response, 8-bit length. And this is the typical normally when you type something and the server is not available. You are familiar to see this type of message. Uh, this type of message 4.0 not found. So this is a message code response actually. A message ID, so it is a message ID expressed in with 16 bits. The COAP request example in figure, you can you can see the figure A. Let me grab the pen for this. So the client, COAP client, requests to COAP server. The message ID is 123 and it is asking about light. So client is asking about light intensity, for example. The server responds to client by sending a message with the same ID. This shows that, yeah. So the message from client side is a type of conformable. So server is bound to acknowledge that once it's received. So when it's received, it sends an acknowledgement message with the message ID, the same message ID, and the response 2.05. This is the light intensity, and it sends the light data. I don't know is it intensity or what, but it sent this value against the request uh, from client. In another scenario, figure B on your screen, right hand side, client send a message, and that the message type is confirmable message type. The message ID 124, and now it's asking about the humidity, but the message is received. So when the message is received, server will not acknowledge it. After some period of time, when that time is passed, the client will again send the same message. Upon receiving, then the server will acknowledge that with the same message ID and the response of the query about humidity. So COAP separate response. In this scenario, you can see this is client send a message. The message type is confirmable, means the server should acknowledge that. This is message ID hexadecimal 1B. Get a light, and it is asking about a light value. And the token is hexadecimal 31. But at the server side, it hasn't uh, the light values at the moment. The server, for example, is waiting from the sensor. So it will send an empty message with the same ID. This shows that the server will, you should, this shows that the client should rest, and as the server receives the requested data, it will send it to COAP. So after some time when it receives the data, the server sends it with confirmable message, and the message ID is hexadecimal 823. 2.05 is the value, and this is the same token number as was present in the client side request. And now the client is bound to acknowledge that message, so it will send an acknowledgement with the same message ID as sending confirmable message from the server. Alright, security in COAP. COAP is an application layer and it needs security. Therefore, so the security layer that COAP uses is Datagram Transport Layer Security (DTLS). DTLS deals with packet loss and does the reordering. And you can see COAP is using UDP and use the datagram. So the reordering of the message is necessary because it is not the message is not transporting in a sequence. So and they are using multi-path. So it may be the case that the last message arrived first, and in that scenario, we must have some mechanism that we ought to put the message on the receiving side. So in HTTP, it is very complicated to know the new states on a variable. Client has to do polling again and again to see that what is the current value. So this is drawback in HTTP. COAP protocol approach offers several specific benefits, and one of them is the use of the UDP for transport. So UDP has less overhead as compared to TCP. TCP is more reliable, but we use UDP intentionally. We want intentionally less reliable is the requirement here. UDP's connectionless datagram enables faster wake up and transmit cycles. So in UDP, the transmission is faster, though it's less reliable. So that with the help of UDP, IoT devices is allowed to remain in sleep state for a longer period of time to conserve the battery power. And another one is that COAP also support many-to-many and multicast requirements. So as I told you, on security side, UDP uh, implement DTLS. So whatever DTLS provides security, uh, COAP benefiting from the DTLS. Resource service discovery. So as you know, in COAP we use uniform resource identifier URI. So from identifier, there are some details that shows that give us a brief picture of the services. So from URI, uniform resource identifier, one can uh, one can imagine that what sort of services that and will provide. Asynchronous communication. So as you know, COAP follow asynchronous communications means COAP one end doesn't need that the other end should be online when one is sending the data. So there might be some case that the sender A is sending the messages and the receiver B is in a sleep mode. So there are some mechanism where we hold the data and upon awakening of B, the data can be sent to B. Web-friendly protocol. COAP has many similarities to HTTP. For user with a web development background, this may make development with COAP relatively easy, like MQTT, the benefits COAP of. So there are some drawbacks as well. COAP is not mature, so still there are some areas where researchers need to uh, work on it. Message reliability. So COAP uses simple approach for confirmable messages and non-confirmable messages. Message reliability, it depends on confirmable and non-confirmable techniques, but it doesn't confirm the correct decoding of its contents. And dependence upon application layer, unlike MQTT, which uses TCP. So COAP uses UDP. This requires the protocol's application that take on tasks usually handled by TCP. So those tasks that's handled by TCP uh, and and COAP using UDP cannot do those tasks. So, but application will do those tasks that uh, TCP is doing. So, in absence of TCP, this UDP depending for this security of tasks on application layer. We have studied MQTT, and now is the time to introduce a lightweight and lightweight, and it uses the UDP actually. MQTT-SN network is an open and lightweight published subscription protocol designed specifically for constrained devices wireless access network. The wireless access network which doesn't have TCP/IP stacks on the top of it, like Zigbee-based wireless access network, they can use an MQTT-SN protocol. So MQTT-SN is designed to be as close as possible to MQTT, and beware that MQTT use TCP, and MQTT-SN is using UDP. So MQTT, in many things, MQTT is close to MQTT-SN is close to MQTT, but is adapted to the peculiarities of wireless communication environment, such as low bandwidth, high link failure, short message length. So if you need low bandwidth, if you have a low bandwidth and and you can afford high link failure, and the message length is short, then the MQTT-SN is the best candidate for your application. It is also optimized for the implementation of low-cost battery operated devices with limited processing and storage resources. So with those attributes, it can use the battery for a longer period of time. And compared to MQTT, the following changes have been introduced in MQTT session. Session number one, the topic names are replaced by topic IDs. So in MQTT, we were using topic names, but now we are using topic ID. And you know the numeric processing is faster than the text messages. Topics do not need registration as and the topic will be pre-registered, not on the time when someone is going to communicate. Messages are also split so that only necessary information is sent. For power conservation, there is an offline procedure for clients who are in sleep state. Message can be buffered and later read by clients when they wake up. It's the same thing that in MQTT, and then why they put it in that. But anyhow, MQTT is also doing buffering, as MQTT-SN is also buffering in third place instead of sending directly to the receiver. So receiver can sleep. If the receiver is sleeping, in, in case, then the message will not be delivered, but it will be stored in somewhere. Clients connect to the broker through gateway devices. The clients cannot directly connect to the gateway as in MQTT. In MQTT-SN, clients connect to the broker through gateway devices which reside within the sensor network and connect to the broker. So based on this, there are different architecture of MQTT-SN. One is MQTT-SN clients, and second is MQTT-SN gateway, and third is MQTT-SN forwarder. Alright, so MQTT-SN, if you see the picture, you have MQTT-SN client on left hand side, and then they are connected to MQTT-SN gateway, MQTT-SN protocols, and this one is also connected with the gateway. So they are connected to the MQTT broker through gateways, and there is one forwarder as well. So MQTT-SN clients connect themselves to MQTT server via an MQTT-SN gateway using the MQTT-SN protocol, as you can see in the figure. An MQTT-SN gateway may or may not be integrated with an MQTT server. So you can see the broker, it is connected to the broker, and it is MQTT gateway. Uh, I can see an example that is not connected to the gateway. In case of a standalone gateway, the MQTT protocol is used between the MQTT server and the MQTT-SN gateway. Its main function is why the gateway is there. The gateway is there because it needs to translate and because the protocol or some other structure is different, so for smooth communication, there would be some middle things that can translate between MQTT and MQTT-SN. And you can see MQTT using UDP and MQTT using TCP and MQTT-SN using UDP. So the message format is also different. So if they want to communicate, there should be a gateway, specific gateway that can translate. MQTT-SN clients can also access a gateway via a forwarder in case the gateway is not directly attached to their network. The forwarder simply encapsulates the MQTT-SN frame it receives on the wireless side and forwards them unchanged to the gateway in the direction. It releases the format. Um, all right, so this is what is this IEEE 802.11? What is it? Do you know? IEEE 802.11 is a Wi-Fi protocol. So the current Wi-Fi protocol is not in a format that can be used in IoT. So the so IEEE researchers, the group that standardize things, they have another IEEE 82.11 AH, a lightweight, low energy version that is designed only for IoT. They have been widely used and adopted for all digital devices. Yeah, so you can read from the slide. It, it's very, it's not that much complex. So synchronization from the basic 802.11 AS MAC layer features include a station is not allowed to transmit unless it has valid medium information that allows it to capture medium and stop packet exchange by others. It can know such information if it receives the duration field packet correctly. If it doesn't receive it correctly, then it should wait for a duration called probe delay. Probe delay can be configured by the access points in 802.11 AS and announced by transmitting this synchronization frame at the beginning of the time slot. Okay, guys, if you have any query, please write in the comment section. I will reply back. Thank you very much. Bye.